Hi everyone, welcome to the Art of the Possible series. I'm Nihali Niyogi and I'm a Principal Cloud Solution Architect at Microsoft focused on advanced networking. Today's topic is HCX MON Mobility Optimized Networking, and this is part 2 where we would cover more advanced scenarios. If you are new to this topic, be sure to check out our part 1 of this series where Victor and I covered more basic scenarios and lab build out. Let's start with a quick round of introductions. Again, I'm Nihali, and my background is in data center networking and security. And prior to joining Microsoft, I worked at a cloud service provider where we ran VMware vCloud Director-based public cloud, and we had implemented NSX back then. With that, I would like to introduce my guest, Jeff Moore, who is a four-time CCIE networking expert from VMware. We also have Dennis, who is our AVS GBB, and Shruti, who is our networking GBB. So with that, let's go through a round of introductions. Jeff, will start with you, Dennis, and then Shruti.
Sure. My name is Jeff Moore. I'm one of the solutions architects focused on Azure VMware Solution on the VMware, now Broadcom side. And Dennis and I have been working with customers who are interested in Azure VMware Solution for the last 5 years. So we will co-present on this topic today. Dennis?
My name is Dennis. I'm a global black belt for EMEA. I'm primarily focusing on Azure VMware Solution, although I'm also focused on migration from on-premise into the Azure cloud.
Hi, everybody. My name is Shruti, and I am a solution engineer with a background with GBB networking.
Hi, everyone. My name is Maisel Jubari. I'm an infra solution engineer. Have been with Microsoft for 6 years and a half, and last 3 years and a half, I've been focusing on networking, network security. And before that, I've been working also on on-prem. I've been a network engineer at Verizon Wireless. Thank you.
Awesome. Welcome, everyone. Great to have you all. Looks like a lot of networking energy here, Jeff, with us. So over to you. We're excited about this.
Sure. And Shruti and May, please keep me honest as we go through this and feel free to ask questions or comment. So
Sure.
Today we'll cover this topic called HCX Mobility Optimized Networking, although first we'll have a quick discussion about what is HCX, and then really why would we ever consider a secondary part of that service called Mobility Optimized Networking. So HCX is mainly for a means of migrating workloads and doing network extensions, but there's a secondary service called Mobility Optimized Networking, and we'll talk about why we would consider that. And if we do go down that path, what kind of prerequisites would we have to consider? And then what deployment scenarios could we look at for different type of options, either layer 2 or layer 3? Okay, so the first topic that we'll talk about is what is HCX, and Dennis will cover that.
All right. So when it comes to HCX, where does it exactly live? Where does it really shine, right? It is designed to facilitate an easy move, a transparent move, a seamless move from everything that is on premise, everything that, from a VMware's perspective, VMs that run on VCF on premise, as well as on platforms such as, KVM and Hyper-V, to facilitate that moving into AVS, which is, the topic of, conversation here, Azure VMware Solution in the Microsoft Azure cloud. Jeff, over to you.
Perfect. Okay, so now we'll talk about why HCX Mobility Optimized Networking, and this tends to be something that we use as a last resort. We try to look at every option possible, but first we'll talk about why we would talk to customers about this option. Okay, so in this diagram we have the on-premises environment on the left, and then the Azure cloud or Azure infrastructure on the right, which includes Azure VMware Solution or AVS. And this is a typical deployment for customers as they want to move from on-premises into Azure or AVS. They might have a 3-tier app and they want to migrate that into AVS. They can do things like, and we'll talk about this, they'll do a layer 2 stretch, mainly to maintain the IP addressing and network connectivity as they move from on-premise into AVS. Although the main challenge as they move that environment from on-premise into AVS is that by default, MON is disabled. So we can only use a single default gateway, even though all these networks are being stretched. So if we were in a close proximity between on-premise and AVS, that would be fine because the latency would be quite small. Although if we were in a situation where the two environments, on-premises and AVS, were geographically distant, let's say West US and East US, we might start to see issues with the application due to inherent latency because traffic has to hairpin back to on-prem. So that's when we start to talk to customers about HCX Mobility Optimized Networking. We enable that on the HCX service. We can enable that service both on the layer 2 stretched networks as well as the VMs themselves. And once we start to do that, HCX will automatically connect a second default gateway on the cloud side. So as you can imagine, if we have that possibility of using the default gateway on the cloud side, we have the option to have more optimized traffic where everything stays on the cloud side, the traffic going to and from versus having to hairpin back to on-prem. And more importantly, traffic that's going from maybe a 3-tier app to some service in native Azure, maybe a storage instance, that also is possible because we have that optimized traffic through HCX MON. And the main thing that we'll talk about is the ability to get to a model or use case that supports symmetrical traffic. And we'll go into more detail, but this is at the high level. Why would we use HCX MON? The main situation would be if we have the on-premises and AVS instance geographically distant, where it creates so much latency that the applications start to have problems as they migrate from on-prem into AVS. We get into this discussion and go through those details as we'll talk about now. So some of the HCX prerequisites. So before we go into the deployment scenarios, there are some considerations that need to be discussed regarding how HCX MON behaves as you deploy it. The first thing that we'll have to consider is what the customer's traffic model is. So I'll probably mention many times the difference between symmetrical traffic and asymmetrical traffic. That'll be the main consideration here as we enable MON. More than likely, we'll start to see asymmetrical traffic, and we'll talk about that in the later use case models. Results may vary if we use hub and spoke or versus non-hub and spoke, but these are things that need to be verified with further testing. And again, if we have asymmetrical traffic where if traffic is going in one direction but comes back a different direction, more than likely that'll be blocked due to stateful firewalls. So if the stateful firewall only sees one leg of the traffic, it'll consider that malicious and block that traffic, and we want to avoid asymmetrical traffic because of that. So what does HCX MON do? It deploys what they call a policy-based route. And for those who are unaware what a policy-based route is, it's just a special static route. A static route effectively says, if I want to get to a destination, here's my next hop. What a policy-based route says, if I want to get to my next destination from this source, here's my next hop. So it considers where the source is as well, and that will be used to direct egress traffic out of AVS, and we'll go into that in more detail. HCX will also inject a /32 host route. So it's a special static route, and it will get injected into the NSX infrastructure within AVS and then get advertised via BGP into the express route backbone. And that allows us to control how ingress traffic is redirected into AVS versus going to somewhere like on-premises. So policy-based route will be built for egress, host route, /32 route for ingress traffic. And we'll talk about that in the diagrams. So before the HCX MON policy, which will be a main piece of the egress traffic, how do we egress traffic out of AVS? The main consideration is what happens before we look at the HCX MON policy. So before it even looks at the HCX MON policy, and I actually got caught by this during my initial testing, it will attempt to communicate to the destination from source to destination using a layer 2 ARP. Now that's a common thing with any layer 2 segment, and that's the same thing here. As we stretch networks from on-premises into AVS, it will also attempt to ARP for that destination across the layer 2 stretch. again, even before it looks at the HCX MON policy. And then if the VM that's been migrated over has been MON enabled and the layer 2 extensions have been MON enabled, it will attempt to look for the destination with the default gateway in AVS. And if it's a connected route, meaning that the destination is on one of the segments that's on that default gateway in AVS, then it can route to and from. So if you extend networks, as we'll show in the diagram, and all the networks are going to the same default gateway, and those VMs have been MON enabled, if it's a connected route on the same default gateway, it will be able to reach the other segments and again, have that optimized traffic independent of the HCX MON policy. But if the destination is not in one of those two options, it cannot ARP to get to the destination, it is not connected to the same default gateway that the source is, that is when it looks at the HCX MON policy to determine how to get to the destination. So that's actually something I got caught on. I could not figure out some results in my testing, and I did not know the first two items. So again, layer 2 ARP, layer 3 connected route, and then HCX MON policy. Again, one thing I always reiterate with customers is that more than likely you'll start to see asymmetrical traffic, and we'll talk about that in the diagrams, but I always remind them to please verify this in the lab. That was part of the demonstration that Nahali, Victor Sandoval, and myself did, so that's something that becomes obvious. Traffic stops when you first enable MON. That's because you probably will see asymmetrical traffic. Pings stop working, and we'll walk through that, but that's usually when we start to see traffic issues. But again, we can correct that with the HCX MON policy. Okay, one other thing to consider is whether or not we enable MON before we do the layer 2 extensions and migrate, or after we do the layer 2 extension and migrate. If we do the MON enablement after we've done the layer 2 extension, so the customer may have not considered HCX MON, they do the layer 2 extension, they start to migrate workloads over, and then they find out, oops, I have an issue with latency and my applications being affected by this, I need to enable MON. If they have that deployment already set up, they have HCX deployed, but HCX MON is disabled, they have the layer 2 stretch going into AVS, and they migrate different workloads, maybe different migration types, bulk, vMotion, and RAV, replication assisted vMotion. These are different migration types within HCX that allow you to move from on-premise into AVS. If they then decide, okay, I'm having a problem with my 3-tier application, I need to enable MON to mitigate that, they can toggle that service on. They would have to manually enable that on the layer 2 stretch. Why? Because it's already been stretched, so you just enable that on the stretch itself. And then because we already have workloads migrated over, anything that's already been migrated over, we'd have to go back and MON enable those. Because the MON service is unaware that that's been migrated, so we have to go back and manually do that. If the decision was from day one to enable MON before the layer 2 extension and before the migrations, the behavior is a little bit different. If we look at this, I'll bring up the diagram here again, we have on-premises and AVS. If we deploy HCX and then have MON enabled from the very beginning, when we do that layer 2 stretch, MON will automatically get enabled on that layer 2 stretch. So it presumes that you have that enabled globally for a reason. So when you do that layer 2 stretch, MON will automatically get enabled. And when you do the migrations, bulk migrations will also get MON enabled. Although vMotions, because they're using the vMotion engine underneath, those will remain in a situation where you have to manually go back and MON enable those. So again, MON will automatically be enabled on the layer 2 stretch, bulk migrations as well, although we have to go back into the vMotion and RAV migrations and manually enable those. And that is called out in our documentation, although this was another nuance that I ran into when I first started testing this. So I put this into the presentation here for reference. Again, we'll share this documentation with everybody. And it's not even important to understand all the details here, but it's just important to understand that the behavior of MON is different if you enable it after you've done an extension and migrations versus having it enabled from the very beginning. Okay, so any questions, comments? Shruti, May, Dennis, Nahali? Oh, yes, Nahali.
So, Jeff, speaking of prerequisites, one of the things that comes up very often and early in the discussion is when we go on a call, there is certain, historical challenges with layer 2 extensions and large broadcast domains. What is your guidance? We see guidance somewhere, it's not a preferred approach. I'd love to know your thoughts on that.
It's a good question, and that question does come up quite a bit. So as we get into customer discussions, the application team wants to do this because it mitigates their issues with latency, although the networking teams sometimes push back and say, well, this is a risk because we're putting a large broadcast domain between two different environments. And I would actually agree with them to a certain extent, although if there's the requirement, if you have the requirement to migrate a workload from on-premises into AVS, and you have the requirement to maintain the IP address, the only option that we have is to do a layer 2 extension. Otherwise, we'd have to re-IP address everything as we migrate because you can only have a default gateway on one side, with the exception of MON. You can only have one single default gateway. So my recommendation has always been use the layer 2 stretch if you have a concern about high availability. You can also deploy the layer 2 stretch with active standby appliances, HCX appliances. Although once the migration is done, tear down the layer 2 stretch, because I would agree that having broadcast domains between two environments like this, even if it was on-prem to on-prem, is something that I would prefer to avoid. Although again, if we have the requirement that the IP addresses have to remain the same, that's really the only way we can do it. Yes, Dennis.
In terms of route limits, right, when it comes to enabling MON, I mean, it's never a good idea to enable MON out of the box, right, for all of the, VLANs that you're going to be stretching. Anything we can say about that?
Yeah, Dennis brings up a good point. So we really position MON as a last resort. The reason for that is because we have to have the right people in the room to understand what that means. As we'll go through the use case models, it is quite intricate. There are a number of things we have to understand from a networking perspective and also from an application perspective. So we tend to use every means possible to provide a design. And then if it's really required, we consider MON. As an example, Dennis and I were working with a customer in Qatar, and they like this idea, although their on-prem and data center were, I think, maybe 50 miles away from each other. So we said, in order to avoid the additional steps that you have to do with HCX MON, you probably can go with a non-MON without using mobility optimized networking design, and you'll be perfectly fine. And that's what they did. So it makes it much more straightforward to just use a standard HCX deployment. Although if we're, again, in a situation where there's a geographically distant, or there's distance between the on-prem and the AVS instance, we have to use that. Did that answer the question, Dennis?
Yeah, and what about, stretching a magnitude of, a higher number of, VLANs, enabling MON on them, simply because they're needed, right?
Right.
In terms of, limits, the amount of routes, right? Limits on the HCX connector, all that stuff. Anything that we can say about that?
Yeah, that's another good point, and something that Dennis and I ran into. So there are upper limits because this attaches to the NSX infrastructure on the AVS side, and there are upper limits. And we can provide reference material for that because it changes on a per version basis, but there are limitations. As an example, when HCX injects the /32 routes, for an average customer, that would be fine. But if you have a customer, very large customers who are moving tens of thousands of VMs and they want to enable MON everywhere all at once, that could be potentially an issue. So that's when we get back to discussions about phasing the migrations, where even though you might have tens of thousands of VMs, you could do an incremental of 1,000 unstretched, another 1,000 unstretched, and then keep moving on from there in order to avoid the upper limits. Yes, Shruti.
Jeff, do you mind going to the previous slide?
Sure.
I just want to understand this better. So when you said first, before HCX MON policy is considered, so when it tries, let's say, you're migrating to AVS, it's stretched, right?
Mhm.
Is the destination on the same L2 segment ARP? If
Correct.
MON is enabled or not, will it not see that it is on that L2 segment? It should still see it, right?
That's correct. So again, that's before what you're right about that. So whether HCX MON is enabled or disabled, it will always attempt to do ARP. But so it's independent of MON. You're right about that. Although these are things that some people tend to forget regarding how network connectivity is handled. So as an example, we ran into a situation where we enabled MON with a customer and we expected everything to go out egress on the AVS side, independent of the layer 2 stretch. We just have to remind customers and partners and teams that even though we have MON enabled and the policy may indicate that the default gateway is on the AVS side, if it's connected to the layer 2 network, it will attempt to ARP first before it looks at the MON policy. So you're correct. It's independent of MON.
Okay, so I want to understand that. It did the ARP policy, it found, oh, it is connected. It is
Yes.
on that L2 segment. Then what would
Yes.
it do? What would be the next thing? Why would it even look at the policy? You see what I mean?
Yeah, so look at, oh, yeah, you're right. So even before the MON policy is considered, it'll attempt to ARP on that layer 2 stretch as it
Yeah.
would on premises. If you have a layer 2 segment on prem, you do an ARP. So it follows that same approach. Then if the workload is migrated over to AVS and MON is enabled on that VM, that's effectively telling the VM that your default gateway is on the AVS side. And we'll talk about that in the diagrams. So it'll attempt to go to the destination. It'll go to the default gateway and say, is my destination here? The default gateway will look to see if it's a connected route. Yes, it'll forward the traffic through. No. Then it looks at the MON policy to find out how to get to the destination. So the MON policy is really only considered before or after, I should say, is only considered after it attempts to do the L2 ARP or look for a destination that's a connected route on the default gateway on the AVS side.
Okay.
And so, Shruti, why don't we, as we go through the diagrams, we'll kind of come back to that because it is nuanced, and this is really going back to Dennis's comment. As we go into customer discussions, they realize some of the complexities here, and they have to get the networking team involved. And we've had large customers deploy this, meaning 200, 300, 400 node environments, and everything's worked fine, although they tend to have a strong networking team involved who understand all the nuances and can test it offline to avoid these asymmetrical traffic situations. So as we get into the deployment models, Shruti, let's circle back to this topic.
Sure. Perfect. Yes.
Okay. Yes, Nahali.
Yeah, so Jeff, I just wanted to call out, in addition to what Dennis mentioned before, that there is also an implication of the 400 route limit on the Azure side when it comes to these /32. That comes up as well.
That's correct. So there are different limitations, and we've hit those, especially if you use something like Route Server.
Mm-hmm.
I have to go back because that's a good point. That was one of our first considerations when we started to deploy MON in Azure, but that also affected our designs. So you're right; those are things that have to be considered.
Mm-hmm.
Although it would always get back to this ability where if the customer can do a phased approach versus saying, okay, we have to do everything at once, because of these restraints, like any design, we'd have to do it in a phased approach.
Yeah, so that has come up in the ARS designs where the gateway subnets would need those UDRs for the /32.
Right.
So I just
That's
wanted
right.
to call that out. And then one last thing, where we are still in the topic of prerequisites, I recently ran into a situation with a customer where they didn't have a DVS on-prem. So if that's the case, then it's one of the most important requirement on-premise to have DVS. Otherwise, they cannot use this.
That's correct. So you're right. For this HCX L2 appliance, So just take a step back here. HCX will deploy its own layer 2 extension appliance. Why? It attempts to abstract any dependencies for the underlying infrastructure. And it also tries to automate and orchestrate the entire process to get from A to B. So in this case, from on-premises into AVS. So it will attempt to, or it will deploy a layer 2 extension appliance and attach to a network. And the network type has to be distributed virtual switch, as Nahali mentioned. So if you're using a standard switch, it will not be supported because we had to decide what type of environments we would support, and DVS, distributed virtual switch, is the only switch we support. So that's a good call out, Nahali, and that's one of the dependencies here. When you do a layer 2 stretch, the underlying vSphere, VCF environment has to support the distributed virtual switch.
Thanks, Jeff. Good stuff.
Okay. Okay, now for the fun part, all the MON deployment scenarios. So we'll kind of walk through this. We'll go through, I think, 4 different models. The first model is just the typical HCX deployment. MON is disabled. This is probably, I don't know, Dennis, probably 80% of our customers who do this, and the 20% will be referencing model 2, 3, and 4. So Dennis, do you want to go through model 1?
Yeah, sure. So in fact, out of the box, when I talk to customers, I try to, leave MON outside of the conversation as much as I can. And it's not that I don't trust the solution. On the contrary, I mean, it's very powerful, but it gets complicated very quickly. So what I'm usually doing is, well, first of all, we try to move the customer to a region as close as possible as to where their data center is. In other words, as we're migrating from, right? And so this is actually the then starting position, right? With the default gateway clearly, on premise, with your layer 2 stretches in place. In this drawing, in this model 1, there's multiple, obviously VLANs stretched here, and our starting position clearly is to the right of your screen. The MON is, disabled, and so therefore there's no default gateway on the AVS side. Everything needs to, route across the default gateway, and then there's several types of traffic, right? That will be shown, here, like for instance, between the green, web to web, right? In this case, anyway, the web to web VM communication. I mean, that's a classic ARP, right? It goes across, that extension, right, across these, network appliances back to on-premise. That's like a, classic, I would say, layer 2. It starts to get a little bit more, I would say, shall we say, latency, aware. When you start, routing, when you start to need that default gateway, right? When it needs to go across into, on-premise and then back, right? Like for instance, the VM to VM communication in the blue line here, right? You're routing across the default gateway, and for that to happen from AVS, from one layer 2, stretch into the other, you'll need to go all the way back to, hairpin back all the way back to your default gateway, and then back into AVS. And the same thing goes for, services that are often, I'm not going to say forgotten, but definitely overlooked when studying the effects of latency, is going back to your, DNS service, right? These things obviously also have to, and usually they are in a separate, VLAN, and so therefore you need to go back to on-premise again across your default gateway, and then back into, wherever you issued that resolve request from. So that is also, I would say, very important, and also something that, will trigger the same effects going back to default gateway is whenever your VMs on the AVS side will have to communicate or depend or talk to a VM that is sitting on Azure, right? And that VM may have already been sitting there for quite some time, right? That it may have, come across after that AVS VM has moved. Well, the same behavior there, right? With MON off is that, you're going to have to go back to your default gateway. So it's a little bit, I would say, counterintuitive, but that will definitely be your traffic pattern, right? Coming out of AVS, going across to your default gateway, and then back out, but then this time to the Azure VNet itself. And the same traffic is exactly right. What that black line here is towards the internet. Same thing, right? You're either breaking out on premise, or depending on where your default route is to the internet, you're going to be doing the same thing. So yeah, that's basically what Model 1 is all about.
Right, and depending on which customer we're talking to and what their situation is, if they have that geographical distance between the on-prem and AVS, and this becomes more evident because of latency, this is when Dennis and I typically get a phone call. So again, most of the customers that we work with can use this, even though all the traffic hairpins back to on-prem during the migration is fine. Although post-migration, everything would be switched over. The layer 2 stretch networks would be unstretched. The gateway on the AVS side would be connected, and everything would be on the AVS side after the migration. During the migration, again, if they have latency issues, that's when we start to talk about mobility optimized networking. Okay. Model 1, yes, Nahali, yes.
Just had a question on that red line that you have, Dennis and Jeff.
Yeah.
Is that showing the DNS resolution kind of going all the way across to on-prem?
Correct.
Okay.
Yeah, correct. It's just trying to reiterate the fact that even though we have all the workloads in AVS and the networks exist on the Azure side, the traffic has to go back to on-premises. Why? Because we only have a single default gateway. So what do we do to resolve that? So we start to talk to customers about enabling MON. So I'm going to just a copy and paste from top to bottom, same exact diagram. Now we'll see what starts to happen. So we'll add some networks here into the diagram. So if people miss that, I'll just do it again. We'll add some networks here so that when we look at the policy, we can follow what that means, but the policy will define where the egress points are. And we'll go into more detail, but this is how we start to control traffic with these special policy-based routes. So on premises, we have the original routes that we had from the very beginning before we started to do any migration, any network stretch. So here we can see 10.118.13 and .14. These are a couple of the networks that are being stretched. Those are being advertised by the original default gateway, which could be a Cisco or Juniper router, independent of HCX, but those are the routes that always existed on premises. And those are also on the Azure side, either via BGP dynamic routing, or they've been somehow built with UDRs, some type of static routes to attract traffic from Azure back to on-prem so they can communicate to each other. So more than likely, those routes maybe is a summarized route. It gives the ability to get that traffic back to on-prem. But just from a simple perspective, those routes exist on both sides. So now all we do is just toggle that switch that Dennis talked about from off or disabled to enabled. And now we can start to, as we talked about in an earlier slide, enable MON on the layer 2 stretches and the VMs because they've already been stretched. And you can see here we also have the gateway connected on the AVS side. So we have a gateway on the on-prem side and a gateway on the AVS side. And now anybody who has a networking background, if we have that with two different gateways, and in this case, it will use the same IP address of the gateway on AVS as it did of the default gateway on premises. Anybody with a networking background would see that as a huge violation because how does the VM decide which default gateway it uses? Because now we have one single layer 2 segment with two default gateways and each default gateway has the same IP address. How does it decide? That's when we come to the HCX MON policy, which we'll talk about in a minute. So again, going back to the earlier discussion that Shruti had commented on, we do the layer 2 ARP. If we can do that, that's great. Because we're on the same segment, whether the VMs might still exist on premises or in AVS, they can go across that layer 2 stretch via layer 2 ARP to connect to each other. If the VMs are now MON enabled, we can communicate to each other because it'll attempt, because we MON enable them, it thinks, or it's been told via the HCX setup or configuration to use that default gateway on the AVS side. If it uses that default gateway on the AVS side and it's a connected route to get to the destination, it will be able to communicate between those VMs that have been migrated over. So here we can see all the segments have been connected to the same tier 1. So it uses that connected route approach. And now we have optimized traffic. There's no need to hairpin back to on-prem as we see in Model 1. And now we can mitigate those latency issues. Okay, at that point, we would think everything's fine, but then we start to see other things pop up, and that really has to do with this concept of asymmetrical traffic in firewalls. So let's take it a little bit further. Sorry, I'll maybe take a step back and say this. So one thing that HCX will do, it will automate, or it will inject /32 host routes, as we talked about just before. I think Nahali, you brought this up. It'll try to bring up these or configure these host routes in NSX, advertised via BGP to the express route backbone, and that will influence your ingress traffic. So as traffic comes back in, the network can make a decision whether or not it's going to redirect that traffic to AVS, where the VM would reside after the migration, or use the original network that was there from the very beginning, the blue routes, to force that traffic back to on-prem. So we're just using the simple longest match rule, like in any router. HCX will inject those /32 routes as the workloads are migrated to AVS, and any traffic coming in or coming back to the VMs will be influenced for ingress because of these /32 host routes. Okay, that's for ingress traffic. The HCX, and then just from a simplicity perspective, or from like a deployment model perspective, use case perspective, we will block those routes because more than likely customers are not allowing those /32 host routes back in. They probably have a firewall there. They're doing static routes to force the traffic and keep that set up static from a security perspective. So we block the /32 host routes back to on-prem. We'll see how that changes in a later model, but in this case, we're going to block those to keep the model simple. Okay, so if you look at the decision tree here, we try to ARP, okay, that doesn't work. We try to go to the default gateway because I'm the VM, I'm MON enabled. I know that means go to the default gateway, although I still cannot get to my destination because the destination is not a connected route. What do I do next? How do I egress? That's when we look at the policy routes. By default, what HCX will do out of the box, it will populate the policy routes with the standard RFC 1918 address space. So 192.168.00/16, 172.16.00/12, and 10/8. These are the standard RFC 1918 address spaces, which are really used for internal networking. That's a starting point. Although it will start to, at least in this case, create some issues with asymmetrical traffic. So let's take a look at what that means. Again, the /32 host routes influence ingress traffic. The policy routes influence egress traffic. So let's say that this, let's look at the MON policy here. Let's say that we want to get to DNS. Okay, so DNS is on the left-hand side. DNS is 10.96.67.2. We look at the policy routes. We know that matches. If it matches, it will essentially tell HCX to bring that traffic back to the default gateway on premises. If it's a no match, it says use the default gateway on the AVS side. Again, it'll look at the policy. If it doesn't match, use the original default gateway on premises for egress. A no match, use the default gateway on the AVS side for egress. Okay. So we have a match because the 10.96.67.2 matches that 10/8. So it will bring that traffic back to on-prem. And because that traffic is already using the standard networks from that default gateway from the very beginning, it'll route that traffic back to the HCX layer 2 stretch and bring it back to those VMs that have been migrated over to AVS. So we have symmetrical traffic because of that. The policy route is telling us to go back to the default gateway on premises, and the return traffic is just using the standard original routes in the default gateway to force that traffic back. So DNS is working fine. In native Azure, for the native Azure traffic, in this case, we have 10.230.3.0/24 in the lower right. We have that one VM on that network. We have a match. So you look at the policy, it still matches that 10/8. So that effectively will mean if a web server wants to communicate to another VM or storage account in native Azure, force that traffic back to the default gateway on premises, and that will go to the VM on the native side. Again, much like we had in Model 1. Now, on the return traffic, because we have these /32 host routes in the Azure backbone, the VM traffic on the return going from the VM in native Azure into the green web VM, it will use a more optimal path because of that /32 route, /32 host route for the ingress traffic. So what happens? It will attempt to go back a different path. We have asymmetrical traffic. Firewalls start blocking it because it only sees one leg of the traffic, and that's when they call Dennis and I. But this is effectively what we will probably hit in every customer situation when we simply just toggle that service on and use the default configuration because of the fact that we'll have matching traffic that will cause it to be asymmetrical. And that's fine. We can mitigate that in the next model. So we'll take it one step further. So for internet traffic, we have a no match, but it's an implicit no match or an implicit deny. Because we don't have the quad 0, so 0.0.0.0/0, we don't have that in the policy on the right, it is essentially a no match. So any VM in AVS that's been migrated over will egress to the internet and then also ingress back to the VMY because we have those /32 host routes. Symmetrical traffic, we're fine. And this is usually when it causes confusion because customers are calling us saying, hey, my 3-tier app works fine, but when I try to get to my storage account, it doesn't work, but I can download any GitHub repository information that I need. It's because of these nuances that we start to see. Okay. Any questions there? I know there's a lot of lines and things like that, but the main thing here to know is that more than likely as we enable MON, it will start to cause, in some fashion, asymmetrical traffic. Firewalls will start to block that when we start to have concern. Yes, Shruti.
I have a quick question here. Jeff,
Sure.
I got most of the part that you explained about the policy, but my question is, after the ARP, right, when it looks at the gateway, why is gateway not able to see the /32s? Why do you have to be dependent on the policy? This gateway is local, right? The NSA.
You mean
you
here
see-
on this side?
On this side, exactly. No, T1, right? Which is the default gateway.
Yeah, you're right. Yeah,
Yeah,
this is the
yeah.
default.
So it should see the /32s, right? Why do I have to rely on the policy?
Okay, so that's a good point. Let's take a step back. So Shruti's right. The /32 routes are injected here as static routes, and then they're redistributed into BGP and then BGP across the backbone. This is really for egress traffic. So the only thing this really tells us for the web, so if this web server wants to connect to this VM, he has to know which default gateway, the on-prem or the AVS side, to egress. They both have the same IP address, so which one do I use? Because HCX has built this layer 2 extension, it's migrated that VM, it can control which default gateway that VM uses. So we can build that decision tree for egress based on this policy. And if we do a match, what it tells the traffic to do, if it's coming from this web VM trying to get to this VM in native Azure, if it does a match, it says send it to the default gateway on premises. If it's no match, send it back here. That's for egress. How do you get out? So that's the egress going from web to VM. For the return traffic, you're right. It will use the /32s to get back, and then we start to get asymmetrical traffic. So this web VM doesn't know that there's any /32s here on the egress because it's being forced, the traffic is being forced back to here and then sent to here for the forward traffic, and then the return traffic is getting back in a more optimal way because of the /32s.
That's okay. Let me just break it down a little bit. Let's say
Sure.
web and app. Let's leave Azure for now. Web and
Sure.
app both have MON enabled, right?
Right.
So when web tries to get to app, right?
Right.
First it does the L2 ARP, then it goes to which gateway to check?
Yeah.
T1.
So in this case right here, they're both, this is before the MON policy. So it's actually number 2 right here. So these two, if they were trying to talk to each other and they're both MON enabled, that effectively means use the and they're on the same default tier 1. Use the tier 1 if it's a connected route to get to the destination, forward it. So effectively it's step 2 here, and that's how we get optimized traffic. But if it's not a connected route, if it's beyond this default gateway, then go to the policy to find out how you egress.
Okay, I see what you mean. So if it is web and app or within the AVS or whole VMware environment, you don't need the policy, right? Even without the policy to talk to each other. Okay, got
Yeah,
it. It's
correct.
for the outside.
Correct.
Perfect.
100%. Yeah. And so this is really good because these are the topics Dennis and I talk to with customers, and at some point they'll say this is not worth it. But if we get the right networking team involved, and they even have questions about how this works. I even had questions, when I first started looking at this, and that's why I put the slide deck together. It's once you know how it works and what the decision tree is, then it's fine. And then more importantly, if we have to start to troubleshoot, and Holly talked about this in the last session, if you look at the tier 0 gateway, so in AVS, the tier 0 gateway is actually locked down, but you do have read-only access. If you look at the tier 0 gateway and go into the IP prefix lists, and then look for this prefix list called prefix list for policy routes, this is the policy route that HCX injects into the NSX tier 0. So it automates that via API calls, and you'll see that these prefix lists down here, it might be difficult because of the resolution, match one-to-one these policy routes in this environment. And then if there's a need to troubleshoot, this is how we do it. We can go back into the tier 0 to verify that these policies were written properly from HCX. More than likely they have, but if there's a need to troubleshoot, then we can do that. Okay. So model 3. Now we'll try to correct this issue with asymmetrical traffic. So simply copy and paste. In model 3, we'll just try to do one step. We'll exclude one destination, going back to Shruti's question. So again, copy paste. It looks like a lot of information, but I copy and pasted everything from bottom to top. MON has been enabled. And the only thing we'll do for the egress traffic, the policy-based routes, is we'll put a deny statement in here for the 10.230.3.0/24, which is the network of the VM in native Azure. Okay. So what that means is, we try to do the layer 2 ARP, that doesn't work. It's not a connected route on the default gateway. Now we look at the policy. Okay, it sees that network, but it's a deny, which means a no match, and we'll see what happens. One thing I will say here as we're getting into this, because we have networking people on the call, as long as we have a match or a deny, or it meets the string longest match rule, it follows the policy set here, but it is not order sensitive like a firewall. So even though we have this one at the bottom and the 10/8 at the top, the longest match wins on this deny statement. It doesn't have to be at the top like a typical firewall rule. As long as it's in the policy, that's fine. So, okay, so now the only thing we've done differently from bottom to top is we've added this deny statement, which will affect the egress traffic if we're trying to get to 10.230.3.0/24. So again, all these different lines we talked about before, those are all symmetrical. Great. Now the web VM attempts to talk to this VM in native Azure. Okay, so 10.230.3.0. Okay, I see it matches closest to here. It's a deny. Okay, so we'll see what happens. So we've gone through all these different steps. Now in the HCX MON policy, when we try to do the native Azure traffic, it does a no match because we explicitly denied it, so it's no match. And now the forward traffic will attempt to go this way through the default gateway on the AVS side because it does a no match, which means use the default gateway on the AVS side. And the return traffic, because it's influenced by the /32 host routes, will go back the same path. We have symmetrical traffic, firewalls are not blocking, pings start working. So this is how we mitigate this asymmetrical traffic situations by updating the policies based on how we want to force traffic. And this gets back to the prerequisites that we talked about earlier. We have to understand what the current traffic behavior is and what the final traffic behavior requirements are. If we go back to Model 1, everything was going back to on-prem. That was very simple. But if we start to get into these nuances where the traffic has to be optimized on the AVS and or Azure side, this is how we influence traffic egress using the policies and ingress using the /32 host routes. And then internet is the same. Now, how can we check that? As we mentioned before, if we go into the tier 0, look at the policy routes, now we see that that policy has been updated with a deny statement, and that's what allows that traffic to be forwarded in both directions symmetrically. Shruti, did that make sense?
Yes, it did make sense.
So as you can, as you can imagine, as Dennis and I have these workshops, and this is presented, it can sometimes cause confusion. I think networking people can absorb it, and with all due respect, the data center teams can as well. Although this is not their daily work. So this is usually a decision point where we have customers saying, "Okay, I think we can remain with the on-prem Model 1 solution for the migration and then take the risk as we migrate." But we've had, again, large customers in Australia and the UK and different areas where they've gone down the path of using mobility optimized networking. It works, it scales well, it's just a matter of knowing these little nuances. Okay, so Model 4 will kind of show a means of making everything layer 3. So as you can imagine, Model 2 and Model 3 really use much of the layer 2 extension to forward traffic to and from on-premises to Azure and AVS, which is fine. This actually is a good scenario where if customers, Model 3 and Model 2 are good work, if customers do not want to update their firewall rules, they don't really have to change very much during the migration, because everything is being sent through the layer 2 extension from on-premises into AVS, and the egress ingress point is the default gateway on premises. So there's really no need to update that firewall, with the exception that after the migration, they would have to come back because those workloads and networks would exist on the native Azure side, which used to exist on the on-prem side. So it really depends on the customer situation. Model 4 presumes that the customer wants to go down a path where the majority of the traffic is using layer 3 from day one. So copy and paste Model 3 to Model 4. What we do here is we take the policy routes in HCX, and we remove all the entries. Okay, so there are no matches. Everything's a no match situation. So if we try to get to anything as we move workloads over to AVS, it will attempt always to use layer 3. Now, in this situation, we have to, at least in this example, we allow the host routes through to kind of keep the scenario simple, but it really depends on what the customer wants to do. And, I think Shruti or maybe Nahali, you had mentioned before, if you have 1,000 workloads being migrated to AVS, that puts another 1,000 workloads, another 1,000 routes into your Azure backbone, and another 1,000 routes /32 routes into your backbone on premises. So there are pros and cons for everything, but in this scenario, just to kind of go through a full layer 3 deployment use case, we would allow the host routes through. Okay, so again, first 2 steps, layer 2, try to ARP to it. Can I get to the destination? Can I use the default gateway on the AVS side to get to the destination if it's a connected route on the same default gateway? Great. We don't even have to look at the HCX MON policy, even if there is one defined. But if we cannot find the destination or reach the destination after those 2 steps, we look at the MON policy. And because we've removed all the entries, there are no matches. So there's no need to forward traffic back to the on-premises default gateway. So in this scenario, if we look at the MON policy, the DNS, so we had DNS in Model 3, it would go across the layer 2 extension back to the DNS on-prem, and then from on-prem back to AVS. Why? Because of the MON policy, plus the /32 host routes were not advertised back to on-prem. So this red line that we have here would be changed because the policy would be, there'd be a no match for the egress, and we have the /32 host routes now being advertised. So that would change to be looking something like this. So if we have For the egress, no match. I use a default gateway on the AVS side. I route back to on-prem. I hit the DNS server. Now I have a longer match rule to get back, and I can get back the same path. Symmetrical traffic, no firewalls are blocking, everything's working fine. Same thing for Azure, as we talked about before, there was no change there. That policy would still be good because in Model 3, we forced or explicitly added a deny or no match. Here it's implicit because there is no thing to match. So that still is the same situation for both forward and return traffic. And internet is still an implicit because it's not specified. So that would still go through the Azure backbone to get to the internet. And if we looked at the tier 0, again, the prefix lists for that, the deny statement is there. So all the traffic is forced via layer 3, with the exception if you're doing a layer 2 ARP. Yes, no.
Sorry, just a quick question, Jeff, going back to your previous slide. I think you covered this in the previous recording, but just because given these are advanced scenarios, could you talk a little bit about the MTU considerations and what you have seen in the field?
Right, that's a good question. So in some scenarios, if we were able to zoom in to this connection right here, maybe looking at this, if this connection between on-premise and Azure is a layer 2 VPN, like an IPsec tunnel, sorry, if the connection between on-premise and Azure is an IPsec VPN or SD-WAN or some other tunnel service, there's a concern where as we deploy these layer 2 VPNs, you'll have a tunnel within a tunnel. So as you deploy the HCX service, there has been the ability to change the MTU size. So if you know that there's an SD-WAN connection between on-premise and Azure or an IPsec VPN, and you want to do the layer 2 VPNs, which also have the option to do IPsec, so layer 2 VPN inside an IPsec tunnel, inside a secondary IPsec VPN, there are going to be issues with MTU and fragmentation. When we deploy the environment for HCX, we can set the MTU in the network profile. We recommend, if you already know there's a secondary VPN, whether it's SD-WAN or IPsec VPN, to set the MTU to 1350 in those network profiles. So as you stretch, you can avoid this fragmentation. Or there's now the option where as you do a network stretch layer 2 VPN, you can disable IPsec VPN on the HCX service. There's no need for HCX to encrypt the traffic in transit because you have that protected already. So you can disable the IPsec, and then there is no need to change the MTU. But Nahali brings up a good point. If you have encryption enabled on the layer 2 VPN for HCX, and you know that there's a secondary VPN, whether it's IPsec VPN or SD-WAN, it's good to adjust the MTU on the HCX side to 1350 in order that you can do a tunnel within a tunnel.
Excellent. Thanks for covering that. Yeah, and we do show how to do it in the lab as well. But I just wanted to call it out here. No, good.
Okay, then I would like to thank everybody for their time. I really appreciated all the input from Nahali and Shruti and May and Dennis. Thank you, Dennis, for co-presenting.
Thank you, Jeff and Dennis. Great presentation. Awesome. Thanks, everyone, for joining, and we will see you in the next video.
Thank you, everyone.
Thank you.
Thanks.
Thank you.
Thank you, guys.